Good morning, good afternoon, or good night. What time you are watching this video? In this video, we are talking about switching because we are talking about NSX. We must talk about switching. It's a layer 2. We are talking about logical switch, VTIP, VXLAN, segment ID, VNI, and transport zone. In this video, I will begin with this picture. As we can see here, if I wanted to connect from host A to host B, I can use cable or hub, bridge, switch, and virtual switch. Cable, I can connect from host A to host B. From host A to host B, I have here virtual machine and here virtual machine. Virtual machine A, virtual machine B. Here, if I use cable, I can connect just one physical ESXi host hosted this virtual machine A to ESXi host hosting this virtual machine B. If I use hub, I can connect more one physical ESXi, bridge more and more, switch more and more and more. But the host has only one VM, only one VM on the ESXi host. If I am using the virtual switch, I can connect multi VMs to our host A, host B. From host A to host B, this switch is inside this host. This host has multi VMs on it. Okay, here I am using virtual switch. It's very useful. It's very nice product inside the ESXi. There is multiple. There is multi kinds of virtual switch. VSS, virtual standard switch. VDS, virtual distributed switch. LS, logical switch. ULS, universal logical switch. VSS is virtual standard switch. I can use it on VMware Workstation. This is traditional virtual standard switch. Virtual virtual distributed switch. It's distributed on all environment under one vCenter. Logical switch. It's port group on the VDS. It can has more than one VDS. This logical switch can connect to more than VDS. Universal logical switch, it's belong to multiple multi vCenter from 2 to 8 vCenters. Here I can see virtual distributed switch has uplinks, uplink 1, 2, 3. Here from host 1, host 2, host 1, host 2. It's for high availability between NICs. Here, it's distributed switch by vCenter. By vCenter. Logical switch, it's by NSX. By NSX, but it's still one vCenter. Under one vCenter. Here I have virtual distributed switch 1, virtual distributed switch 2. Virtual distributed switch 1 has port group. This port group is engineering here, and here port group is in for engineering. Here I have logical switch between two virtual distributed switch. Here uh, engineering port group VMs can connect to VM here in VDS from this VDS2 to VDS1. Here it's cluster 1, here it's cluster 2. Here universal logical switch by NSX here from 2 to 8 for vCenters. Here if I have side A and side B, here I have universal logical switch, as we can see here, web logical switch, app logical switch between two sites in my environment. Here VTP, VTIP, VTIP, it's VXLAN tunnel endpoint. VXLAN tunnel endpoint, it's a tunnel like you can imagine like a VPN tunnel between two hosts. It carry VXLAN traffic from host A to host B. Here, when I config the NSXi, NSX, if I config NSX, I must has VTIP pool here from A to B. Here, VTIP it has an ID for node 1 and node 2 and create VXLAN tunnel. It's working through 4789 UDP port. I must allow this port on my firewall if I have firewall between node 1 and node 2, ESX1 and ESX2. Segment ID, it's or VNI, it's VXLAN network identifier. VXLAN network identifier. It's ID for VXLAN. It's like here. VXLAN 1, VXLAN 2, VXLAN 3. VXLAN 1 has VNI 5000. VXLAN 2 has 5001. VXLAN 3 5002. If the traffic go from ESX1, it must capsulate, must has VXLAN header has VXLAN ID from A to from ESXi1 to ESXi4. Here in ESXi4, the ESXi4 de-encapsulate the is packet and see what VXLAN ID to give the information to VM on VXLAN 5002 if I send the information from this virtual machine on the same VLAN. Here I have VXLAN header, as we can see here, this frame encapsulated by VXLAN technology. VXLAN has VXLAN ID is VXLAN identifier. Okay, encapsulation from host A to host B, as we can see here, VM1, 1 and 2, reach VM1 here. The encapsulation in the NIC, add the VXLAN header to payload and travel to destination. Here, the encapsulation works here to VM1. Okay, here MTU must be 1600. 1600 because we add additional information on our packets. Let's see. As we can see here, this is information in NSX controller. Let's talk about NSX controller. NSX controller has all information from my environment. Has all information from my environment. Here, let's see here how it's can collect all information from my environment. When I add the host ESX or host ESX host to NSX environment, it the ESX NSX add an engine here. This engine collect all information on the host and virtual machines, MAC addresses, IPs, operating system. This information from VM tools to agent, from agent to controller. Here in NSX, we have NSX master node. This master node has all information in our environment. Here, as we can see here, if we execute this command, show logical switch controller master VNI, as we can see here, this information on all hosts and this belong to uh, VNI 5000. If I ask a question, the performance of the switches will decrease because if I have additional information here, I must has additional performance. I will lose performance because I has additional information. Okay, but I will not lose uh, uh, very much performance. Here, if I have 10 gig bandwidth, I will lose 0.16 only, and it's not so big if I have NSX. Here, how the switch, how the switch created when the manager, when the admin create a VNI, create a logical switch. The logical switch has the NSX manager give the new logical switch free segment ID from the pool. Here the pool, uh, as we can see here, 5000. This information sent to vCenter. The vCenter creates the for logical switch on the ESXi hosts. This information also go to NSX controller, as we can see here, and the agent give the NSX controller all information on the NSX. Transport zone is very important for isolation. If I have a multi transport zone, each transport zone uh, hosts or clusters can reach each other. Uh, Here I have the transport zone 1 connect to all hosts. These hosts uh, can reach each other here. But in NSX, transport zone 2 has these hosts and reach each other. Okay. Transport zone here has multiple points. Only one universal transport zone. This transport zone, universal transport zone, it's uh, in across its work across vCenters. Okay, if I wanted to collect information, or um, uh, I want to control multi vCenter through the transport zone, I can do that by NS universal transport zone. This transport zone uh, can belong to vCenters, multiple vCenters. Multiple vCenters can connect to this transport zone. Universal transport zone include clusters from any vCenter in the environment. We can create one universal transport zone on our environment. Okay, one uh, NSX can contain one or more transport zone, not universal transport zone, but only one universal transport zone in our environment. A cluster, host cluster, can belong to multiple transport zone. Multiple transport zone. Okay, logical switch belong only one transport zone. Only one transport zone. Here, if I have site A and site B, if I have site A and site B, if I must has I must has three segment pool, one for host A for site A, and two for site B, three for universal transport zone. Here we are talking about logical switch. It's a port group on VDS. VTIP, it's a logical tunnel between hosts, can carry VXLAN information. VXLAN we have VLAN, we have VLAN ID. When we have VXLAN, we have VNI. Okay, and transport zone for isolation. Thank you very much, and see you later.